All right, our chapter here is all about physics, motion, forces, Newton's laws. So there's your heading for today, motion and forces. Newton's first law, and I'd like you to write this down. Newton's first law of motion: an object at rest will remain at rest, and an object in motion will continue moving at a constant velocity unless acted upon by a net force. So something resting wants to stay at rest, something moving wants to stay moving, unless something changes that. Okay? For example, if I throw a ball, that ball wants to continue moving unless forces are acting on it. Now, here on Earth, the forces that will act on that is friction with the air, like wind resistance, and gravity will pull that to the ground. So if I throw a ball, it's eventually going to fall down because of gravity and friction, wind resistance. If I roll a ball across the floor, it will eventually stop because of the force of friction. If you go bowling, a bowling ball will roll a long ways because there's less friction. They wax those floors. The bowling balls are shiny. So there's nothing to slow it down very fast. If I was out in space and I threw a ball, because there's no friction and no gravity, that ball would go on forever until it ran into something. So Newton's first law: an object at rest wants to stay resting, and an object in motion wants to stay in motion unless something acts upon it. All right, so a big question: is your desk moving? Some of you will say no, which, relative to me or anyone else, it is not moving. That would be correct. Some of you would say yes. And if you said yes, you might say, well, the Earth's spinning, so of course it's moving. Or you might break it down into simple atoms and say, well, the atoms are vibrating. Yes, it's moving. Both of you would be right. You need a reference point, which is a non-moving point to measure your motion. Motion, I would write this down: a change in position in relation to a reference point. So if you say a rabbit hop past that tree, you would say that rabbit is moving because you're comparing it to the tree. The tree is the reference point. The little cave guy is moving in comparison to the tree. Okay, so if you're sitting in your chair reading this sentence, you are moving. You're not moving relative to your desk or your school building, but you're moving relative to the other planets in the solar system and the sun. So it's all about what you compare it to. Okay? Some of you may say I'm tall. Well, compared to you guys, yes, I am. But if you compare me to NBA players, I am not. So it's all by comparison. Some of you may think you're very intelligent, and compared to kindergartners, you are, but compared to college seniors, you are not. So it's all what we compare it to. I would write down the red stuff there. Distance. Distance describes how far an object has moved. Distance describes how far an object has moved.
Do you have the key to the weight room?
I do.
I gotta check fire extinguishers.
Mm-hmm.
Okay. I'll bring it right back.
Yep. When you compare distance, in science, we're going to use the SI unit, which is metric. We're going to use meters or kilometers. Shorter distances will be centimeters. Write down the red, please. Displacement is the distance and direction of an object's change in position from a reference point. So displacement is how far you are from the original spot. So suppose you're a runner and you jog for 50 meters. and then you turn around and run back 20 meters. Your displacement is 30 meters. So you went 50 meters from home, you came 20 meters back. So your displacement is 20 meters. The distance, or the distance that you ran is 80. So the distance is how far you ran. Displacement is how far you are from your original point. So the runner runs here, runs back. He's 20 meters from where he started, but he ran 50 plus 30, that's 80 total. So you are a passenger in a car stopped at a stop sign. Out of the corner of your eye, you notice a tree on the side of the road begin to move forward. What's really happening? Is the tree moving? I would say no. Instead, you are moving. You set yourself as a reference point. Maybe this has happened to you. It usually happens with big vehicles. You're at a stoplight, and it appears like you're moving backwards, but really the big vehicle next to you is beginning to coast forward. Let's stop there.